Hello, Professor. My name is Raul Barrera. I'm a student in your physics class, and this is my video explanation for word problem 24.66. So I'm going to start off by reading the problem. That way I can explain my work. So it says a parallel plate capacitor is made from two plates, 12.0 centimeters. From two plates, 12.0 centimeters on each side and 4.0 millimeters apart. Half of the space between these plates contain only air, but the other half is filled with plexiglass of a dielectric constant 3.40. An 18.0 volt battery is connected across the plates. So for part A, they want what is the capacitance of the combination. Hint, can you think of the capacitors as an equivalent or two capacitors in parallel? Okay, so I'm going to try to do a video edit of my work right next to my webcam. I already had it done, so it's easy for me to explain. I'm just going to go highlighting over it, and that way you follow along with me. So, let me test this color. I think white will be best. Okay, perfect. So for 24.66, we have 12.0 centimeters each side. Yeah, I like that color. There. 12.0 centimeters each side and 4.5 millimeters equal apart. So for part A, the formula that I will be using, well, the expression I should say, is C equals E0A over D, which K equals to a dielectric constant. So to get the dielectric constant of plexiglass, I use this formula. C1 over equals K1 E0A over 2, which is what we have over here, D. So then this is the constant of the dielectric plexiglass, and then K2 will be the constant of air, which is C2 equals K2 over A2 over D. Then it leaves us with this. So the effective capacitance of the parallel combinations of the capacitors is C equals C1 plus C2. So then it's C equals K1 E0 A over 2 over D plus K2 E0 A over 2 over D. This leaves us with E0A over 2D K1 plus K2. So the area of the capacitor is A equals L squared. L is the length of each plate. Sub 12 centimeters for L in AL2. So A equals 12.0 centimeters. That leaves us with 12.0 centimeters times 10 to a negative square meters over 1 centimeter squared. That's a formula to simplify. And then we need to sub 3.40 for K, 1 for K2, 8.05 for C2, and then for E0 it's 4.0. And so on. It's 0.014 meters for 4. And then this is the formula we have, which is 8.85 times 10 to the minus 12 c squared over n times m squared times 0.014 meters squared 2 times 4.50 meters times 3.401, which is this right here. Then this over here is the separation to the second formula, which is essentially the same thing. All we're switching is what we're multiplied by. Instead of 3.4, this time we'll do 4.40. And we get this. 6.23 times 10 to the 11th, which that is the effectiveness of the I'm sorry, I can't pronounce that word very well. The capacitance, which is 6.23 times 10 to the negative 11F. So what we did, we got the distance, we solved for each one, and that left us with the energy effectiveness. Then for B, we need to get the energy stored in the capacitor. So I'll be using this formula, which has come in very handy in learning physics. So then what we have to do is we have to sub things into the formula. So we will be substituting this for C and 18 for V. And then we'll be putting in the formula, which is V half 6.23 times 10 to the negative 11, which is what we got here, which is times 18V squared. It gives us this. And then when we simplify this, it's 1.0 times 10 to the negative 8. And then is part B, which is rounding off to significant figures, the energy stored in the capacitor. This is energy stored in capacitor. Now part C, which was the trickiest, which you want to see the result when the plexiglass is removed. So if we remove the plexiglass, then the total space will be this. Will be the formula because we have to subtract. It's 0 C to 0 equals E0A over 2D. Then we have the two constants, K2 plus K2. And we get this left with this. When we simplify, we have this. And then we have to use this, but we have to use substitution. So for K2 is equal to 1, E0 is equal to this, D is equal to 4.50 millimeters, and then A is 0.0144 meters squared. Then with all this information, we plug it in and we work like this. This is part A, which is 8.85 times 10 to the negative 12 power C squared over n times n squared times, right here, 0.0144 meters squared divided by 4.0 millimeters times 1 is the first part. We simplify the next step will give us this. So we have to substitute. When we substitute for here for k squared and this, we have this, which is essentially this same top part. However, we are dividing by this to simplify. That will give us 2.832 times 10 to the negative 11 F. And I'm trying to read it. Okay. So now this is a change. This is the formula we're going to be used for this change in energy stored. Okay? Energy stored, which is 1.009 times 10 to the negative 8J for U, and then 0.4588 to the 10th negative 8 joules for U0. When we plug that into the formula, we get this. When we solve it, we get this, and that is the energy stored in the capacitor. It was a difficult question, I'm not gonna lie, but with the formulas, energy stored, with the formulas of removing space, using the area of the capacitor, which is, if I'm not wrong, it's A equals length square, and when we use for example, the first formula, which is C1 equals K1, E0 A over 2 over 2. That's what I use to get K1 of the dielectric of the plexiglass, and then K2 the dielectric of air. So I'm going to use it to combine. And yeah, that is my solution. If you have any more questions, I will re-explain it. I speak a little too fast, and sometimes I get ahead of myself when I'm speaking, but I think my work should explain it. Thank you, Professor. Hope you're doing better. Have a good day.